welcome to new strength and new thoughts. Today, the topic of my presentation is ways of presenting data under the supervision of Professor Dr. Saira Afzal. Learning outlines, data and its types, general methods of data presentation, use of numbers in organizing data, tables, charts, graphs, diagrams, box and whisker plots, stem and leaf plots, MCQs. Learning objective. At the end of the presentation, participants will be able to describe different methods of presenting data. What is data? Any piece of information that can be measured, like height and weight, judged as age about 50 years, assessed as malnourished, or observed as yellow coloration of the skin. Types of data. Data is further divided into qualitative and quantitative data. Qualitative data is further categorized into nominal and ordinal, whereas the quantitative is further divided into discrete and continuous data. Three general ways of presenting data: numerical methods, tables, charts, graphs, and diagrams. Use of numbers in organizing data. Nominal numbers, numbers that do not represent amount or quantity. They are used to identify a person's status, category, or attribute. They are used for nominal data. For example, in the above data, 1 and 2 are the nominal numbers. Mean of nominal numbers cannot be computed. Ordinal numbers. These numbers represent an ordered series of relationships. An example given below, educational status numbers are ordinal numbers, 1, 2, 3, 4. Ordinal numbers only indicate position in an ordered series, but says nothing about magnitude of difference between two successive entries. Like in the table given below, 1 indicates illiterate, 2 indicates metric, 3 graduate, and 4 postgraduate. Interval scale. Involve assigning numbers at equal intervals from an arbitrary origin. The arbitrary selected origin does not imply a true absence of the characteristic. Fahrenheit and Celsius temperature scales are example of interval scale. Because interval scales don't have an absolute zero, ratios of scores are not meaningful. 60 degrees Celsius is not double as hot as 30. But because 0 degrees Celsius does not indicate a complete absence of heat. pH is also an interval scale. Ratio scale. Ratio scale is interval scale with a true 0 point that reflects the absence of the measured characteristic. When the variable is 0, there is none of that variable. Blood pressure, age, body weight are all ratio scale variables. Presenting data in the form of tables: simple table, frequency distribution table, cumulative frequency table, and relative frequency table. Simple table. How to make a simple table? Depending upon the number of variables and frequency, make columns and rows. Columns and rows should be appropriate, clear, and concise with proper headings. Overcrowding of columns and rows should be avoided. Data should be presented according to the importance and magnitude. The table should be numbered on the left upper corner. The table should have a brief, comprehensive, self-explanatory, and easily understandable title at the top. If table has been borrowed, do give reference at the right bottom. In this example, it shows method of delivery of 250 babies born in a hospital in July 2013. Frequency distribution table. How to construct a frequency distribution table? First, we arrange the data in the ascending order. This will make our task easier. Then we will locate the highest and lowest value of the data. Then we will calculate the range by subtracting the lowest value from the highest value, and then we will determine the number of classes required. Calculate the class interval by dividing the range by the number of classes required and desired. Construct the classes and make the table with rows and columns. Label each row and column clearly. Tally the data as tally marks as 5-bar gate. Convert tallies into counts and frequencies. Give table number and the left upper corner. The following table shows the marks scored by student in this column. 41, 49, 50, 58, 59, 67. These are all the class interval hairs. The following column shows the tally marks, and this column shows the frequency. Frequency distribution table. In a glance, it shows where the main concentration of value lies. It shows the range and shape of distribution used for descriptive summaries of both quantitative and qualitative data. Cumulative frequency table. This table tells us the cumulative frequencies below the upper limit of class. Cumulative frequency table shows us the number of frequencies having a measurement less than or equal to the upper boundary of the class interval. Cumulative frequency is required to calculate median of the group data. It is also required for constructing cumulative frequency polygon. The following is an example of the cumulative frequency distribution table. The cumulative frequency, as shown in the last column, is obtained by adding 2 plus 4, we get 6. Similarly, by adding 6 plus 6, we get 12. By adding 12 and 2, we get 14. And adding 14 plus 6, we get 20. Relative frequency table. Many researchers prefer to work with a relative frequency distribution that contains percentage or proportionate frequencies rather than raw frequencies. Relative frequencies must be used when data sets with different sample sizes are compared. Relative frequency table. Ages in years of 25 students in a class of BSc noted in 2013 are listed below. How to construct a frequency distribution table for this data? We will arrange the data in an ascending order and similarly calculate the class intervals. Then we will tally the data and count frequency. Relative frequency, however, is calculated by dividing 11 with the total frequency, which is 25, and then multiplying it with 100, we get 44, which is the relative frequency. Bar charts. They are useful methods of presenting data by the length of the bars. They are frequently used because they are better retained in the memory, have a powerful impact. They are an easy way of expressing statistical data of nominal or ordinal variables. Categories or variables are displayed as rectangles of equal width with height proportional to the frequency of the variable. The following example shows the bar chart. Admissions from January to May in a hospital of Rawalpindi. Multiple bar charts. 2 or more bars pertaining to the same category can be grouped together for better and easy understanding. For example, we want to express the number of students, both boys and girls, in each group in the class. Component bar charts. The simple bars are divided into 2 or more components. Each part represents certain variable proportional to the magnitude of that variable. These are called component or stacked bar chart, as shown in the following diagram. Expenditures of school 1 and 2, the bars are divided into different components showing the expenditure of school 1 and 2. Pie chart. It is a circular chart and shows differences in the frequencies or percentages between categories. The area of a pie is taken as 360 degrees, representing relative frequencies in a wedge-shaped proportions. It is used for qualitative data. For example, the pie chart shows the percentage of male and female children. Histogram. Frequently used for quantitative data, it consists of a series of adjacent bars. The height of each bar indicates frequency. X-axis contains quantitative value of the variables of interest, and Y-axis depicts the frequency. A gap only exists if a class interval has zero frequency. A histogram has no gap between the bars. The gap only exists if a bar has a zero frequency. The following histogram shows the heights of black charities. On x-axis, there is the numerical value of the variable, whereas y-axis depicts frequency. Frequency polygon. It is appropriate for quantitative data. X-axis contains numerical value of the variable and y-axis represents the frequency. It is constructed by joining the midpoint of each class interval of a histogram. It is constructed by plotting midpoints of each class interval with the corresponding frequency and then by connecting these points with each other by a straight line. The following two diagrams shows the conversion of a histogram into a frequency polygon. As you can see, height is given on the x-axis and number of students on the y-axis, and by joining the midpoints of the class interval of each histogram, we get a frequency polygon. Cumulative frequency polygon, which is also called an ogive. To construct an ogive, an ordinary frequency table has to be converted into a cumulative frequency table. We place a point at the upper class boundary of each class interval in front of the corresponding cumulative frequency. It is completed by connecting all the points with a freehand curve. Percentile may be obtained from an ogive. On x-axis, values of the variables are given, and on y-axis, cumulative frequencies. Its shapes resemble the English letter S. As you can see in the diagram, cumulative frequency is given on the y-axis and height on the x-axis. Pictogram, it is the pictorial presentation of data for easy understanding of a common man. Line diagram. It is used to show the trends of events with the passage of time over the period of time. Future predictions can be presented efficiently in this type of presentation. Figure shows the trends of profits for a company. This is a line diagram. Scatter diagram. A scatter diagram is used to examine the relationship between both the axes, x and y axis with one variable. In the graph, if the variables are correlated, then the point drops along a curve or line. A scatter diagram or scatter plot gives an idea of the nature of relationship. In a scatter correlation diagram, if all the points stretch in one line, then the correlation is perfect and is in unity. However, if the scatter plots are widely scattered throughout the line, then the correlation is said to be low. If the scatter points rest near a line or on a line, then the correlation is said to be linear. The following shows the perfect positive correlation, and this diagram shows the perfect negative correlation. Similarly, if the points are scattered close to the line, it is a high degree of positive correlation. Similarly, this is a high degree of negative correlation. The following diagram shows the no correlation. Stem and leaf plot. A stem and leaf plot is a special table where each data value is split into a stem, the first digit or digits, and a leaf, usually the last digits. For example, 32 is split into 3, stem and 2, leaf. And how will we tabulate it? We will make 2 columns, stem and leaf. For example, in 15, 1 is the stem and 5 is the leaf. Similarly, in 16, 1 is stem and 6 is the leaf. Similarly, in 21, 2 is the stem and 1 is the leaf. 23, 2 is the stem and 3 is the leaf. 26, 2 is the stem and 6 is the leaf. 30, 3 is the stem, 0 is the leaf, and 32, 3 is the stem and 2 is the leaf. Box and whisker plot. A box and whisker plot is defined as a graphical method of displaying variation in a set of data. In most cases, a histogram analysis provides a sufficient display, but a box and whisker plot can provide additional detail while allowing multiple sets of data to be displayed in the same graph. Box and whisker plots are very effective and easy to read, as they can summarize data from multiple sources and display the results in a single graph. Box and whisker plots allow for comparison of data from different categories for easier, more effective decision making. Box and whisker plot, also called a box plot, shows the 5-number summary of a set of data: minimum, lower quantile, median, upper quantile, and maximum. Following is the article I found on the time for a new data presentation. It's called Beyond Bar and Line Graphs, Time for a New Data Presentation Paradigm. Figures in scientific publications are critically important because they often show the data supporting key findings. Our systematic review of research articles published in top physiology journals suggests that as scientists, we urgently need to change our practices for presenting continuous data in small sample size studies. Papers rarely include scatter plots, box plot, and histograms that allow readers to critically evaluate continuous data. Most papers presented continuous data in bar and line graphs. This is problematic as many different data distributions can lead to the same bar or line graph. The full data may suggest different conclusions from the summary statistics. We recommend training investigators in data presentation, encouraging a more complete presentation of data, and changing journal editorial policies. Investigators can quickly make univariate scatter plots for small sample size studies using our Excel templates. MCQs. A researcher wants to graphically represent gender distribution in the study. Which of the following is the most appropriate method? A. Histogram, B. Frequency polygon, C. Ogive, D. Pie chart, E. Scatter plot.
Histogram.
No, it's pie chart because pie chart is used for the categorical data. A researcher wants to present the world population estimates in million for 10,000 BC to 2050 AD. The most accurate way of presenting his data would be A. Pie chart, B. Bar graph, C. Scatter diagram, D. Line diagram, E. Stem and leaf plot.
D. Line diagram.
Yes, it's D. Line diagram. A researcher wants to compare distribution of data of 3 studies in which weight of children are taken. The best method to compare distribution of data set will be A. Bar charts, B. Box and whisker plot, C. Stem and leaf plot, D. Scatter plot, E. Line diagram. It's B. Box and whisker plot because box and whisker plot is used to compare the distribution of data from different studies in a single graph. As a public health expert, you want to show that 1 in 7 women suffer from breast cancer in a rural community. The best method to raise awareness in the community by posters will be A. Bar chart, B. Histogram, C. Pictogram, D. Area map, E. Stem and leaf plot.
C.
Yes, it's C. Pictogram. Which of the following is the interpretation of the scatter plot given below? A. Strong positive correlation, B. Strong negative correlation, C. No correlation, D. Positive correlation, E. Negative correlation. It's a strong positive correlation. As you can see, the dots are close to the line. A student graphically represented distribution of age in study by bars with no distance between the bars. After that, he joined the midpoints of all the bars to make a curve. Which of the following curves would have been drawn? A. Ogive, B. Frequency polygon, C. Scatter plot, D. Line diagram, E. Stem and leaf plot.
B.
Yes, it's B. Frequency polygon. The diagram shows the transaction amounts per customers in front of the corresponding cumulative frequency. What is the following diagram called? A. Frequency polygon, B. Ogive, C. Line diagram, D. Scatter plot, E. Box and whisker plot.
C.
No, it's B. Ogive. The suitable diagram to represent the data relating to the monthly expenditure on the different items by a family. A. Bar charts, B. Pie charts, C. Histogram, D. Compound bar chart, E. Stacked bar chart. It's B. Pie charts. In a cumulative frequency polygon, the cumulative frequency of each class is plotted against A. Midpoint, B. Upper class limit, C. Upper class boundary, D. Low class limit, and E. Low class boundary. It's C. Upper class boundary. A stem and leaf plot of a number of hospital admissions per day is shown. List the data values for the given stem and leaf plot. Anyone? Is it A, B, C, D, or E? It's C. As you can see, this is the following key. Thank you. Please subscribe and like the YouTube channel of the Community Medicine.
Thank you very much, Dr. Alishba. Very nice presentation, especially the part that you have presented is again reflected in your MCQs. Very well done. And Allah Hafiz.
Thank you, ma'am.